Alright, so this video we're going to look at graphing cosecant function. Now, uh, in order to graph cosecant, you need to know how to graph the sine function. And in this video, I have three examples. I'm going to do one example is going to have its own video. One of them will be just a regular, straightforward, you know, graphing. Uh, Another one, it'll have a left or right shift in it, and then that'll be example 2. And example 3 will have a left or right shift, and it'll have a up or down shift in it. Okay, so check all three of them out. Alright, so first let's just look at graphing a sine function. So if we have y equals sine of x, okay, as long as you can graph this, you can graph a cosecant. So just real quick, we know the period is equal to 2 pi over b, and b is the number in front of x, so we can see in this case b is 1, and so our period is 2 pi. And if we graph this, and we're going to graph it over one period, we'll graph it from 0 to 2 pi, and we know that, and we need to break this up into 4 equal intervals. Okay, so we'll go halfway between 0 and 2 pi, which is pi. Then we'll go halfway between pi and 2 pi, and remember, to go halfway, it's just pi plus 2 pi is 3 pi, and then half it, so 3 pi over 2. And then halfway here, 0 plus pi is pi, divide that by 2, that's pi over 2. And the max and min, the amplitude's 1, so our max and min is 1 and negative 1. And I do have a video on the sine function, graphing it. Check that out. It goes into a lot more detail than what this does. Okay, this video's kind of assuming that you know how to graph a sine function. Alright, so what we know about the sine, once we break it up into these intervals here, we know the sine function starts out at 0, and then it goes to its maximum, and then it goes back to 0, and then it goes to its minimum, and then it goes back to 0. And so this would be our sine function. That would be the graph of the sine. But the main thing is getting these points here. Okay, you got to get these points here, and then you know that it goes 0 max, 0 min, 0. Okay, alright, so let's take a look at our example. Alright, so this video, let's look at it, example 2, graphing a cosecant function. So as I said earlier, in order to graph cosecant, we need to graph the sine function first. Alright, so we need to find the period, how we're going to, what period we're going to graph this over. And you know, you can find the period as 2 pi over b, and then as you can see in this problem, we have a plus pi over 2, which is our phase shift. Instead of finding that, I'm going to show you a easier way to find the interval that you graph it over. So let's just first go ahead and write down the y equals negative 1/2 sine x plus pi over 2. That's what we have to graph first, and we're graphing this as a guide. Okay, it helps us draw the cosecant function. Alright, so to graph this sine function, and I do have video on graphing sine functions, got a bunch of examples in there, so you might want to check that out. But what we do, instead of, finding the period and then finding the phase shift, what we can do is this part in parentheses here, we can set up this inequality and put it between 0 and 2 pi. Okay, so whatever you're taking the sine of, put it between 0 and 2 pi and just solve for x. So here we'll subtract pi over 2 to everything, and that is going to give us negative pi over 2 is less than or equal to x, less than or equal to, and then 2 pi minus pi over 2. Let's see, that's going to be what? 3 pi over 2. Okay, so this is the interval that we're going to graph over. All right, so let's go ahead and draw our x and y axis. See if I can draw that a little better. All right. Oh. All right, now notice I put the y-axis in there. Now you think I should have done that because see, my endpoints are one's on this side of the y-axis and one's on this one, so I don't know how close to put it. I don't know where everything's going to fall. So for right now, let's not even put the y-axis in there, and let's just extend that on like this, and let's mark off negative pi over 2 and 3 pi over 2, and we've got to break this up into 4 equal intervals. Okay, so I need the midpoint between negative pi over 2 and 3 pi over 2. So let me come over here and show you how to do that. So to find the midpoint, I just take the two endpoints and add them together. So that's going to give me 2 pi over 2, which is pi. And then once I add them together, then I have to half this. So that's pi over 2. So I just half it, pi over 2. And so the midpoint is pi over 2. Okay. And now I need the midpoint between pi over 2 and 3 pi over 2. So I'm going to add them together. Pi over 2 plus 3 pi over 2, that is 4 pi over 2, which is 2 pi. Okay, and then I have to half this, so I take the 2 pi and I half it. That gives me pi. So the midpoint here is pi. All right, and then I need the midpoint between negative pi over 2 and pi over 2, which hopefully you can see that's 0, but let's just go ahead and work it out. So negative pi over 2 plus pi over 2 is 0, and then I have to half the 0, and which gives me, of course, 0. So there's 0, and we know that this is the y-axis. All right. Now, to graph this thing, well, I need the max and min value. Well, we know the amplitude is 1/2. Okay, it's the absolute value of the number in front of the trig function. And so I know my maximum and minimum value is going to be 1/2 and negative 1/2. All right. Now, here's the beginning of the period, and here's the end of the period. And if you remember the example problem we did at the very first, remember sine starts out at 0. Okay, and then sine goes to its maximum. But look at this, since we have a negative in front, instead of going to its maximum, it's actually going to go down here to its minimum, and then it goes back to 0. Okay, so remember sine goes 0 max, but because of the negative it's a min. Okay, but 0 max 0, and then it goes to its minimum. But since there's a negative, instead of its minimum, it's actually going to go up to its maximum and then back to 0. Okay, and now I can sketch in the sine curve, and when we do this, we sketch it in with a dashed line. Okay, this is not part of the graph. This sine function is not part of the graph. That's why we put it in as a hidden line, a dashed line. All this is a guide. Okay, and then if you remember, the cosecant function is 1 over the sine function. And you can see here at negative pi over 2, pi over 2, and 3 pi over 2, the sine function is 0. So that means we would have 1 over 0, which would be undefined. Okay, so since the sine is undefined at these values, I'm sorry, since the cosecant is undefined at these values, that's where we're going to have our vertical asymptotes. Okay. And then once you have your vertical asymptotes drawn, you see where it comes down to its minimum here and its maximum here on the sine function. That's where we put what we call our U-shaped branches in. And so the cosecant function would look like this. This could come on down further. And then here. Okay. And there's your graph of cosecant. So I hope this helped. Give me a like, share, and subscribe. Check out the other videos, and thanks for watching.